Hey guys, welcome. This is the IT trainer. Hey, this is the first part of a multi-part series on cloud computing with an emphasis on the Microsoft Azure cloud space. So we're going to start off from the beginning. We're going to talk about the basics, what is a cloud, all the different aspects of a cloud. We'll talk about what a service is and all the different things we can do with clouds. Then we're going to transition into videos that are demonstrations in the Azure portal where I'll actually be building resources and talking about all of the details of building resources. And of course, showing you how we use web services to connect to those resources, which hopefully, in combination with all the lecture we're going to do up front here, will give you a well-rounded view of actually what a cloud is and how you can use it. Okay, so again, this is going to be a multi-part series. I'll try to keep each of these videos to between 15 and 20 minutes. I think from an attention standpoint, that's probably a good thing to do. Please do me a favor, guys. I'm not a YouTube content provider or maker per se. I'm a trainer. I've been doing this since 1994, not on YouTube. But if you have questions or comments, please put them in the comment section. Number one, that does help the video in terms of getting out there so people can see it, which is my goal. And also, like the video and subscribe because I'm going to do a whole lot of videos now on this channel over the upcoming years for sure, and you won't want to miss any of those. All right, well, let's go ahead and get started. This series of videos is about cloud computing. So let's first start talking about what cloud computing is. And before I really get into what cloud computing is, would you mind spending a couple minutes with me? Let's talk about what traditional IT looks like, traditional data centers, and so forth. Because if we understand what a traditional data center is and what traditional IT is, then when we start talking about the cloud, that'll really be illustrative of the differences between the two. So in a traditional data center environment, we actually have a section or a part of our office space, our office building, geography, wherever that is. No matter how big it is, it could be 1,000 square foot, 5,000 square foot, but it is a dedicated room, if you will, that is highly secure, locked down, and inside of this traditional data center, if you will, this is where we would have all of our mission critical servers. This is where you would find firewalls and switches and routers and racks of equipment. A lot of the data centers out there have raised floors. Underneath of those raised floors, that's where all the cabling chases are. The cabling is run there, going between rack after rack after rack, right? All of this stuff, including, I might add, all of the environmental controls to keep those computers nice and cool. Because again, you're in a 2, 3, 4,000 square foot room with hundreds of servers in there. If we didn't have HVAC to keep that place cold, man, it would get hot really quickly and ultimately could damage your system. So it's from an HVAC standpoint, we keep those rooms very cool. Everything in that data center is highly secure. We don't allow our users to go into that data center and log on to those servers. We have a dedicated team of IT professionals, administrators, and the like. Sure, some, not all, some of them will go into the data center and manage those servers, whether they're backing the servers up, whether they are rebooting things, whatever they need to do. But the employees, they're on their desks, they're in their cubicles, they're at home, and they're gaining access to resources within that data center over the network, right? So they're accessing resources over the network in the data center. Perfect example. You go to work, you're sitting at your cubicle, you fire up your Outlook connection. Outlook goes out over the local area network into the data center and connects to a Microsoft Exchange server, which is, of course, Microsoft's email server. Okay, they didn't walk downstairs to go down to the basement, to go into the data center, to log on to the Exchange server to get their email. No, they're at their desk doing their job. They have map drives to servers in the data center. They have Outlook, which connects to mail servers in the data center. They use browsers, whatever their browser of choice is, to connect to the intranet website, the SQL database. Everything is in the traditional data center. Now, the traditional data center costs a lot of money. There is capital expenses that are massive to build and maintain and manage and secure traditional data centers, right? They're buying potentially thousands and thousands and thousands of servers. I'm not making that number up. You know, enterprise organizations with 5, 6, 700,000 servers in data centers, they're out there. Yeah, there's data centers with 200, 300 servers. There's data centers with 10 servers in it. I get it, but the point is, you had to buy all of those servers up front. That is a capital expense. You had to buy the racks. You had to buy the cabling. You had to buy the computers. You had to buy the software. You had to buy the operating systems. You have to buy and maintain the licenses. You have to buy the employees and pay them a salary, whether the salary is paid weekly, bi-monthly, every 2 weeks, whatever the scenario is. There's a lot of upfront money in a traditional data center. Now, let's transition that into cloud computing because, man, it's very different. You see, we're not dealing with a traditional data center with all this physical stuff around. We're not even focused on the hardware aspect of anything because we don't have access to that. The cloud service provider maintains massive, massive data infrastructures throughout the world. We are piggybacking on top of their hardware and building virtual environments. So instead of having a physical data center, I have a virtual software-defined data center that I am piggybacking on top of, and it was all provided or is provided by the cloud service provider. Cloud service provider. That's why we say cloud computing refers to a service model, because the cloud service providers are providing what? They're providing computing services that we or our customers or our remote workers, they connect to over or through the internet. And of course, if you look at modern IT nowadays, man, this whole cloud thing is blowing up. It is the industry to get into now if you're going to be getting into IT. It is one of two of the most important industries, security and the cloud. I'm not saying general IT, general networking, routing, switching, all those other things isn't great, but certainly the cloud and security are where it's at in modern networking. Cloud computing has grown rapidly over the past 3 to 5 years. And again, the big difference here, hopefully you've heard this or you've understood this, the big difference between cloud computing and your traditional IT is two things: where your IT is actually located and how you pay for it. In traditional IT, your data center is where it's located, in a building, some property that you own or you rent, and you pay up front for all of that. And your costs are applied both up front with what's known as capital expense and also ongoing, which is operational expense. Like for instance, you have employees that manage and work in the data center where you're paying them every couple of weeks. You're paying them $100,000 a year. Well, that's an operational expense. That's the cost of doing business. A capital expense is up front. Okay? You're paying for it, then you're given it. Right? If you go to your favorite car dealer to buy a new car, they're not going to give you a car and then you pay for it. No, you're going to pay for it and then they're going to give you the car and you're going to drive away. That's a capital expense up front. You've budgeted for that. So when we compare conventional computing services to cloud computing, you really want to wrap your head around this the same way you would think about a utility bill in your house, an electric bill, a water bill. Okay, whatever the bill is, you pay as you use it, right? Typical utility bill. You leave all your lights on in your house. You keep your air conditioning at 58 degrees year round. Every single light's on all the time, even when no one's home. Your electric bill is going to be a lot higher than someone else. When they leave the house in the morning, they turn everything off. They keep their air conditioning on maybe 72, 74 degrees, and they're gone and working all day. Then when they come back, they turn on any light they need in any room, but when they're no longer using that room, if you will, turn the light off. Keep the air conditioner down. Your electric bill is going to be a lot less. You are paying for what you're consuming. This is an operational expense. You are paying for the workload on the servers or applications that you're hosting in the cloud, in other words. If I build a system, a virtual system in the cloud, I'm not paying for that system, with some exceptions that we'll talk about throughout this series, but I'm not paying for that system up front. I'm not dropping 40 grand on some high-powered server when I build one in the cloud. No, it's free. Now, once my customers start using it, once my employees start using it, there's workload being developed on that machine. Processor utilization goes up, RAM utilization goes up, network storage utilization and IOPS goes up. That is like leaving more lights on and leaving your HVAC system in your house cooler. You're going to pay more for that. When no one's using that resource, you're not paying for that resource. Maybe you're a 9-to-5 business. Everybody is gone by 5:30, 6 o'clock. No one's accessing your servers in the cloud. You're not paying for that. Okay? You're paying some limited money for it, but very small compared to if you had to go to Dell, drop 40 grand on a server, and then you bring it back eventually 20, 30 days. It comes to you in the mail, then you hook it up. Well, you paid the 20, 30,000 for it already. It's gone. Before you even received it, you drop the cash on that system. Okay, some big differences between traditional IT and also the cloud here. So what is cloud computing? Look, I don't care if you're going to go apply for a job in cloud or if you're going to take a certification. There is one universally accepted definition by the National Institute of Standards and Technology, known as NIST. Cloud computing is a model for enabling ubiquitous. Okay, first let's take this definition. I'm going to break it down. We'll talk about its pieces, then I'll read the whole thing again in one fell swoop. Cloud computing is a model for enabling ubiquitous. Now, what does ubiquitous mean? It means it's everywhere. Okay, the cloud is literally everywhere. I don't care where you are in the world, you can connect to your resources. Number two, convenient. 24 hours a day, 7 days a week, 365 days a year. I can gain access to my cloud resources, whether I'm going to manage them, whether I'm going to consume them. They're always there and they're everywhere. This is on demand. When I need access to networks or servers or storage or applications or any other service in the cloud, I have access to it. It's when I want it, I get it. On-demand network access to this shared configurable pool of resources that are out there being hosted by the cloud service providers, like Amazon Web Services, like Microsoft's Azure product, like Google Cloud Services, or the IBM Watson Cloud, etc. Okay, now, these resources that I may want to build or modify, I can do this rapidly. Okay, if your boss comes to you tomorrow and says, hey, I need you to go buy a new web server. We need another web server. Why don't you go to Dell and spec a web server? We need a new one. Oh, we're doing really well. We're about to introduce some new products. So you say, okay, no problem. You get out on the web, you go to Dell.com, you're looking at all their servers, you come up with one that you think is going to work. You go to your accounting department, you get a purchase order, turn it into an invoice, the whole 9 yards, you pay your bill. 20, 30 days later, the server shows up. And yeah, 20, 30 days nowadays, turnaround time on servers is not unheard of at all. So what I just described, there's nothing in that entire description that says it's rapid. Rapid provisioning is, and you'll see it when I do it in our future demos. You log into your Azure portal, your Amazon Web Services portal, you want a new virtual machine, you open up a wizard or you run a script, boom, 3 minutes later, 4 minutes later, it's done. There's your virtual machine already on your network, already out there on the internet, already serving your customers in a matter of, let's just say, worst case scenario, 5 minutes. That's rapid. That's rapid provisioning. The opposite of rapid provisioning is releasing it. Hey, I don't need it anymore. Now try that one with Dell. You just bought this high-powered web server, dropped 40 grand on it. Oh man, you know what? We don't need it. 6 months from now, we were wrong. We don't need it. What are you going to do? You're going to call Dell in Dallas, Texas and say, hey, Michael Dell, you know, I bought this server, but we really don't need it. I'd like to return it, get my money back, right? And then, of course, when Michael Dell starts laughing at you and you hear a click of the phone, you'll know why. There's no way they're taking it back. There is no releasing of physical equipment. That was a capital expense. You paid for it. As far as it's concerned, your budget is now negative in terms of losing that amount of money. Not in the cloud. If I don't need that virtual machine, I go in and delete it. Boom, it's gone. Guess what? I'm not paying for it ever again. I build another one when I need it. Don't need it anymore. Boom, it's gone. Right? Holiday season's coming up. Let's set up a couple of web servers to sell our products. Holiday season's over. Boom, they're gone. Not paying for them anymore. This is rapid releasing of resources, and I didn't have to go crazy doing it. It wasn't a lot of work to get rid of it, and I certainly didn't have to call the service provider, the cloud service provider, to do it for me. Now, I could if I wanted to, but I certainly don't have to. So, what is cloud computing? NIST says any cloud worth its salt better have these 5 things. On-demand self-service. When I need to create something or manage something or remove something from the cloud, boom, I do it. No matter what network I'm on, no matter where I am, broad network access. If I'm on my iPhone, if I'm on a tablet, if I'm on my Windows 11 workstation, if I'm using a Linux system, whatever it is, a Nexus tablet, I can gain access over Wi-Fi and fiber and copper. As long as I have an internet connection, I can gain access to it. Broad network access. Resource pooling, a pool of resources that I have access to at any given time. And from that pool of configurable resources, I can build my virtual servers, I can host applications and containers, I can host functions in a serverless environment. We'll talk about all of this throughout our course, right? Rapid elasticity means I can build an infrastructure where if my virtual systems need more resources at any given time because the workload increased, we can automatically on the fly give them resources to handle the workload, and when they no longer need it, boom, they release those resources back to the configurable pool, and that server is right back to where it was before I needed those resources. Again, go to Dell, buy a computer. I want 64 gigs of RAM. I want 8 processors in it. Okay, and that's doing great. But all of a sudden, the holiday season's over. I don't need 64 gigs of RAM and 8 processor cores. So let me go ahead and send those back to Michael Dell. Let me send them back. Not going to work. There is no elasticity because it's all physical. It's all there. Elasticity means my virtual machine starts off with 2 processor cores, 6 processor cores, enough RAM to get the thing booted. As the workload increases, more processor cores, more RAM are magically added to the system. And then when the system doesn't need them anymore, it releases it, and now I'm not paying for it. It's almost like your light switch turns itself off because it knows no one's in the room. That's why we do this. Rapid elasticity, fantastic. And of course, it's all measured. What does it mean it's all measured? Just like your electric bill is, right? You've got an electric meter on the side of your house or something, some other kind of a device that measures the kilowatt hours you're consuming. And then they bill you for the kilowatt hours you consume. They bill you for the gallons or liters of water you're using. You go to a gas station, fill up your gas with 10 gallons or 5 liters, you pay for that. You don't pay for more, you don't pay for less. This is a measured service. So the 5 elements that any cloud must have: on-demand self-service, broad network access, resource pooling, rapid elasticity, and a measured service. Now let's go back as we wrap up this first video and read this definition. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, example networks, servers, storage, applications, and services that can rapidly be provisioned and also released with minimal management effort or service provider interaction. Know that definition, because that is the only universally accepted definition. In part 2 of this video series, we're going to get into more details about different types of clouds and whatnot. Thanks, guys, for hanging out with me for the first one. The second one is coming shortly, and I look forward to seeing you there. Don't forget, if you have questions, please use the comment section. Please give it a thumbs up if you liked it. Even if you didn't like it, give it a comment, give it a thumbs up. That's going to help us out here at the IT Trainer. Thanks, guys. We'll talk to you soon.